Welcome back to the Explainer. Okay, let's just dive right into it. Today, we're tackling an absolute pillar of NestJS architecture, Providers and Dependency Injection. If you're building modern, scalable backend applications, this is really where the magic happens. We're going to unpack exactly how NestJS organizes your code to keep it modular, testable, and highly efficient. To set the stage, let's think back to our previous look at controllers. We established that controllers are essentially the dashboard of your app, right? They receive those inbound HTTP requests and figure out which part of your app needs to respond. But think about your car's dashboard for a second. When you step on the gas pedal, the pedal itself isn't spinning the wheels. It's just signaling your intent to accelerate. So when your controller gets a complex request, like saving a user to a database, who's actually doing the heavy lifting? Building on that metaphor, if the controller is the dashboard routing the signals, the provider is your engine. The controller says, hey, I need a list of all the cats in our database, but it shouldn't be the controller's job to go into the database, run the query, and format the data. Instead, it delegates all that complex business logic to a provider. By separating the routing from the actual work, your whole application becomes so much easier to maintain. Section 1. Meet the engine providers. Now, what's really interesting is how simple Nest makes this concept under the hood. Let's formally meet them. At its core, a provider in NestJS is really just a plain old JavaScript class. The most common type you'll write is a service. For example, if you have a cats controller, you'll probably create a cat service. This class just holds your logic, like a create method to save a new cat or a find all method to retrieve them. The beauty of wrapping this in a plain class is that you can easily reuse it anywhere in your app. But how does NestJS actually know this plain class is meant to be a provider? Well, the answer is this simple but incredibly powerful decorator, @injectable. Think of it like a magical barcode that you slap right onto the top of your class definition. When you add @injectable above your cat service, you're attaching metadata. You're raising a flag and telling the NestJS runtime, hey, this isn't just a regular class. This is an engine, and it's ready to be managed by you. Section 2. The assembly line, dependency injection. Which brings us to a really critical question. Who actually builds this engine and drops it into the car? You see, in traditional programming, if your controller needed a service, you'd have to manually instantiate it by typing out new cat service function. But NestJS uses a powerful design pattern called dependency injection, and it's driven by an inversion of control or IOC container. Basically, think of the IOC container as a highly advanced robotic factory built right into Nest. Instead of you manually building the engine and wiring it to the dashboard yourself, you just tell the factory what you need and it handles the whole assembly for you. And this brilliantly illustrates how that automated assembly line actually works in practice. First, your controller just asks for the service by declaring it in its constructor. Second, when the app runs, the Nest IOC container sees this request. Because of TypeScript, Nest resolves this dependency based entirely on its type. It goes, they need a cat service. It finds one or creates a new one. Finally, the container automatically injects it directly into your controller. It is seamless, it's instant, and it is completely hands-off for you. Now, this architecture isn't just magic for the sake of being flashy. As the official docs point out, this setup enables you to design following solid principles. Because you're relying on the IOC container to inject dependencies, you're naturally loosely coupling your code. Your controller doesn't need a clue about how to build the cat service, it just needs to know how to use it. This makes everything incredibly robust and a total breeze to test. Section 3. Customizing the factory, provider scopes. Of course, our automated factory is only as good as its configuration. It needs to know how often to actually build these engines. Since not all dependencies are the same, Nest gives you 3 distinct lifespans. By default, it uses the Singleton scope. That means the factory builds exactly one instance of your engine and shares it across the entire application, super memory efficient. But let's say you have data tied to a specific user's request. You'd use the request scope, where a brand new instance is spun up for every single incoming HTTP request. And finally, there's transient scope, where a fresh, dedicated instance is created every time a consumer asks for it. Honestly, 99% of the time you're going to stick with Singleton, but having these options lets you really fine-tune performance. Section 4, the blueprint, registration. So we've got our @injectable engine, and our automated factory is ready. But the factory isn't psychic. It needs a blueprint. So the absolutely crucial point here is provider registration. If you don't register your provider, NestJS will throw a massive error, simply because it doesn't know your engine exists. To give it that blueprint, just open your module file, usually app.module.ts, find the app module decorator, and add your cat service straight into the providers array. Once you do that, the blueprint is complete and the factory can get to work. Just a quick aside before we wrap up. While constructor-based injection, asking for the dependency right there inside the constructor function, is definitely the standard, Nest does offer alternatives. For instance, if you have deeply nested class inheritance, passing dependencies up through super can get pretty messy. In those cases, you can use property-based injection by dropping an @inject decorator directly on a class property. But as a general rule, stick to the constructor. It keeps your required dependencies right at the top of the file, making your code super easy to read at a glance. All right, let's step back and look at the whole shebang. You know how to separate your routing into controllers, the dashboard. You know how to handle business logic with providers, the engine. And you've seen how the NestJS IOC container acts as this brilliant automated factory wiring them together. But I want to leave you with a thought. Right now, we just have one dashboard and one engine. What happens when your application grows massively? What happens when you have dozens of dashboards and hundreds of engines? How do you keep the factory floor from devolving into total chaos? Keep that in mind, because that exact challenge is what we're going to solve when we dive into NestJS modules. Thanks so much for joining me on this explainer, and I'll catch you in the next.